You're looking at a sprawling web of conditional logic, a massive, tangled gate array where data pathways clash and create aggressive bottlenecks. For computer science students, FPGA hardware engineers, and full-stack developers, decoding this dense knot of operations requires an enormous amount of cognitive load. The engineering objective is to compress these redundant strings down to absolute mathematical efficiency, and to do it without losing your rhythm. But the sheer friction of untangling this raw logic creates a wall. It forces engineers out of their peak flow state and turns a simple optimization task into a painful, grinding bottleneck. Traditionally, resolving this mess meant pulling out a notebook, drawing up Karnaugh maps, and calculating complex Boolean algebra entirely by hand. Relying on manual calculation introduces serious liabilities. A tired engineer can easily drop a single variable on line 40 or accidentally miscalculate a De Morgan's inversion. Those tiny mathematical errors compound. In the real world, an unoptimized equation translates directly into bloated software algorithms, excessive power consumption, and eventual hardware failures. Manual logic reduction represents a systemic risk to the integrity of an entire project architecture. To eliminate that manual math, the Prime ToolHub Boolean Expression Simplifier operates as a dedicated algorithmic engine. You input your formulas using a smart virtual keyboard designed with pre-built templates, dropping in complex NAND, NOR, and XOR equations instantly without fighting standard text formatting. The engine applies null, identity, and absorption laws, visually crossing out redundant sections like AND B. Expanding downward, it lists the exact mathematical laws applied step by step. Beside it, a binary truth table perfectly matches the ones and zeros, confirming absolute logical parity. By automating the mathematical proofs and providing a transparent workflow, this engine completely replaces hours of agonizing verification with instant, error-free certainty. Sending proprietary FPGA circuit designs or back-end routing algorithms to an external cloud server for simplification introduces an unnecessary vulnerability. To protect your data, Prime ToolHub built this simplifier on a localized client-side JavaScript engine. Processing everything directly in your browser yields a dual advantage. You get zero server latency for instant mathematical reduction, paired with total user privacy. Your sensitive, proprietary logic equations never leave your local machine, eliminating workflow delays and securing your project architecture. When you apply this mathematical reduction to physical technology, the manufacturing economics improve. Fewer required gates mean digital circuits become noticeably cheaper to produce and consume far less power. On the software side, stripped-down conditional logic prevents the CPU from evaluating unnecessary statements. Back-end algorithms execute faster, consuming a fraction of the computing cycles. And for the human doing the work, the friction disappears. The engineer remains locked in a steady, uninterrupted flow state. The gap between chaotic, raw input and flawless mathematical efficiency is closed without sacrificing a single second of your productivity. Accessing this computational engine requires zero friction. There are no signups, no registration pages, and absolutely no paywalls blocking your workflow. Prime ToolHub doesn't use data harvesting forms or forced accounts. You simply load the page and start calculating. Stop relying on manual calculation for complex hardware designs and risking your project momentum on simple mathematical errors. Compress your complex equations into perfectly minimized logic for free right now at primetoolhub.com.